Hi, and welcome to Allen High School. This is pre-AP chemistry level discussion of reaction stoichiometry. And we're just barely into our discussion. Thank you for joining us. What we're going to look at, we've already looked at moles to moles. Now we're going to do mass to mass. There's your little heading on the side there. Now I'm just going to jump right in. You always want to write your reaction. So it says how many grams of sodium chloride could be formed, okay? And we're looking at the theoretical amount. A stoichiometry, you always need pure reactants, and this is the theoretical amount that goes into it. So I'm forming sodium chloride, and you do need to be able to predict reactions when we form them from their elements. Okay, and then we want to balance this. So I need a 2 here and a 2 there. Now, when you're working these, you want to write your givens underneath whatever is being referenced. So I have 30 grams of chlorine, and it says how many grams, question mark, grams of sodium chloride would I need? Now, I don't have a conversion factor that relates these mass to mass. We've got to go through that heart of chemistry called a mole. All right. Now, I want to go from mass to moles. Mass to moles, use molar mass. And then I want to go moles to moles. And when I do moles to moles, I'm going to use the magic mole ratio. And then I'm going to go moles to mass using the molar mass. Okay, so 3 steps. Now, this step you know, so let's kind of take a look. That step you knew from last unit. This step you knew from last unit. The only thing that's new is the magic mole ratio. Now, when we're counting points, you would earn a point for writing a reaction if it wasn't given, and you can earn a point of partial credit if you lay out the map. So let's take a look at where we're headed. I'm going to use the railroad method this time. This is going to be 3 steps. So I'm going to start, and then I'm going to go to mass, and then my magic mole ratio, and then my last step. So we're always going to start with our given, 30.00 grams of chlorine. If you don't label that chlorine, you're going to get lost. I can almost guarantee it. So my first step is to get to the mole. So I often think of this as a mole road. So our goal is to pull out of the driveway onto the mole road. So I want to eliminate grams. I want moles. Mass to moles, use molar mass. 1 mole of chlorine, Cl2, don't forget that's diatomic. Write that, do your brain dump at the top, 70.90 grams, and we're still talking about chlorine. Grams of chlorine cancel. Now, if I was kind of at a map at the mall, there'd be a little, person there saying, you are here, all right? Now I want to do the next step. I want to eliminate moles of chlorine, label, label, label. And I want moles of NaCl. You can put it on top, I don't care, just label where you are. Now, if you'll set the units up to cancel, then all you have to do is look up to here for our mole ratio numbers. There's a 1 in front of the Cl2, and there's a 2 in front of the NaCl. Now, do you notice that this is always where you're going to over where you're coming from? That's one way to make sure that you've set up your magic mole ratio properly. Now, I can't stop here. I've just driven down the road, pulled up in front of NaCl's house, and now I got to pull into the driveway. So I want to eliminate moles of NaCl, and I want grams of NaCl. Moles to mass, use molar mass. A sodium plus a chlorine is 58.44 grams. All right, now if you did all of that algebra correctly, and notice I have 4 significant figures in my first number, my answer is going to be 49.46 grams of NaCl. Final answer. Now, this problem would give you a point for the reaction, a point for the map, a point for that step, a point for this step, a point for that step. Usually we'll give a half a point for each molar mass, and then a point for units. So you can really rack up those points just by showing me each step of your brilliance. Let's go on to another one. This time I have potassium chlorate, and potassium chlorate decomposes. So I've got KClO3. I heat it. That delta over the arrow tells me to heat. And I'm going to go to KCl plus O2. Honestly, I'm not so worried about states at this point. It's not so critical to our conversation. Now I do have to balance this, so I need a 3 and a 2 and a 2. Okay. Now, we're assuming 100% yield. That's what theoretical yield, that's what my maximum is. So that's what I'm after, is that maximum yield. It's the most I can make assuming perfection, or we often call it the theoretical yield. Those are terms you really want to wrap your brain around right now. Now I have 400.0 grams of potassium chlorate. And I need to, oops, boy, I just messed that up. Put it in the wrong place. Read it carefully. I've got 400 kilograms of potassium chloride. Oh, Dina, messed that one up. There we go. So I need that. In order to make a certain amount of money, to be able to make my payroll, I need to make 400 kilograms of KCl. So what do I need to start with? How many grams? Now, we can't go directly mass to mass. There's no shortcut here. We have to use our mole ratio. So the first step is to get to moles. Well, that's actually a little bit of a two-stepper here, because we first have to get to grams and then to moles. And then I can go moles to moles, and I'll label those clearly in a second, and then I can go moles to mass using molar mass. So we're going to go to kilograms, then to moles, then from moles to moles, and then from moles back up to grams. Laying out your map will give you direction. You really, really, really must do that. Don't take shortcuts. If you take shortcuts, you're bound to get lost. Okay? So I'm going to get my start, then I've got to go to grams, then I need to go to moles, then I need to go moles to moles, and then moles to mass. So that's my layout. Got 400.0 kilograms. I want to eliminate kilograms, so you thought you could forget all about those prefixes, didn't you? Remember Saturday Night Live? The scientific notation by the lonely base unit, the one without the prefix. So that gets rid of kilograms, and you really want to label what you're talking about. We're still talking about KCl here. Okay. Now I want to get from grams to moles of KCl. So I'm right here, and I want to go to here. So I pulled out of the garage, but I'm still in the driveway. I want to get out to my mole road. For every 1 mole, if you look up KCl, it is 74.55 grams of KCl. I'm here on my map. Want to drive down the mole road, set up your units to cancel. I want to eliminate moles of KCl and go to moles of KClO3. Now, I grab those exact numbers so you see where I got them from. So there's a 2 in front of the KCl and a 2 in front of the KClO3. If you put 1 to 1, I wouldn't mark it wrong. But if you were missing it, you risk losing a point, especially if your answer is wrong at the end and I'm trying to find credit for you. Okay? All right, we're right here on our map. And notice that it's to over from. Where you're going to on the front end of the arrow over where you're coming from on the back end of that arrow. Now, I want to eliminate moles of KClO3. I want moles of I want grams of KClO3. Mass to moles, use molar mass. So 1 potassium, 1 chlorine, and 3 oxygens is 122.55 to 1. So double check, grams of KCl cancel, moles of KCl cancel, moles of KClO3 cancel, and I'm left with my final. And to 3 sig figs, it's 6.575 times 10 to the 5th grams of KClO3. That's going to be your final answer. Okay, now let's go on. I think I have time for one more in this video. Let's forge ahead. All right, this time we're still going mass to mass. Bromine is, and remember that's diatomic. Don't forget to put that however you memorize it, your little phrase or ditty for memorizing. React completely. Now, element plus ionic is a single replacement. Ha, you thought you could forget that, didn't you? No such luck. Balance, and we're good to go. So this asks us how many grams of bromine are required to react completely with 45.70 grams of lithium iodide. Okay, so now we want to map out our issue, our problem. We've got to go from mass to moles, then we want to go moles to moles, and then we want to go moles to mass. All right? So mass to moles, moles to moles, then moles to mass. Hopefully you're getting a hang of these. So let me set out a grid and let's forge ahead. I've got 45.70 grams. It's like I'm in the driveway at lithium iodide's house. I want to pull out of the driveway onto the road in front of lithium iodide, but I'm still talking about lithium iodide. Wow, have I suggested that you label what you're talking about yet? Just wondering. I'm assuming you can get these molar masses. If you don't know where I got that number from, you need to come see me so I can help you some more. All right, I'm here. Now I want to go moles to moles. I want to drive down the mole road. I want to drive away from lithium iodide's house, and I want to drive to bromine's house. There's a 2 in front of the lithium iodide and a 1 in front of the bromine. Remember, to over from. A 1 is where we're going to. We're traveling. I see that 2 coming up too many times there. All right, and the 2 in front of the lithium iodide. Now I want to eliminate moles of bromine. I want grams of bromine. 1 mole is 159.8 grams. Okay. And if we crank through all of that algebra and round it to the correct number of sig figs, we get 27.28 grams of bromine. Okay. Now, we're going to do some more of these, and I think you like this. This is a unit students really grasp by and large pretty quickly, a few little tweaks here and there. So until I see you in class and I can help you some more, this is signing off.